There are situations where we want our code to perform a particular way, or even in real life, as you move across the city of Accra, there are some places you see a lot of security presence. Other places, no one cares. When you move to the Flagstaff House, you see a lot of military people guarding the president. Not because we don't trust ourselves, but because we know the value of whatever is there and the kind of people who stays around and the vulnerability around that area. So you know something can happen. So if you know something can happen in a particular situation, you must prepare ahead. You must be proactive in your coding. Being proactive in your coding means understanding exception handling. If you suspect something to be happening in a particular locality, in your code, you mark that area as what? Potential out of way code session by using the keyword try. By using the keyword try. Or if you suspect something happen, first you mark that area. Then after you've marked that area, you go inside that area and look at in the internally. At this point, if something happens, this should send this signal. At this point, if something happens, this should send this signal. Then when you send a signal, someone must receive the signal and act accordingly. So if someone tries to attack the president just by the roadside, he drives carelessly, you send maybe misbehaving on the road signal, and maybe the police will handle it. But when you realize that it's like some missiles coming from somewhere, that one, you throw what? The signal to what? Burma camp. That is a serious threat, a national security something. So the military people will come in. Then they'll come and handle it, contain it. That's handling. Containing the situation is the handling. It's the same with the exception handling. When it comes to exception handling too, in Java, you have 5 main keywords. Try, catch. So I'll create a project, Safe Town or Safe Country. You have try, catch, throws, throw, and finally try, throws, throw, catch, and finally. The try is the demarcation of that area. So if you suspect an area, you put it in a try catch, meaning you are putting it under a watch. You are monitoring it. Then within that area, as you are monitoring, you need to set some set points or save points or flash points within that area. Those flash points is where you throw your point. So the throw are within the tries, and the throw is the save point or the flash point within the try area or the demarcated area. Then just after the try, another team will be sitting waiting for the what? Whatever is being thrown to be catched. So that's the work of the catch. Now when the catch catches it, someone must handle it. That's why it will be handled in the catch. There are situations where you don't set flashpoints inside the code. The place is so large that if you have to set flashpoints inside that locality, you will never finish. So the whole area, you set one big flashpoint, maybe at the entry of the town. So if something happens, just throw this. I don't want individual locations. That's where the throws comes in. So throws usually works on a block. Throws on a block, and that block is usually a method. So you put the whole method under the throws. While throw is within normal smaller block or within the try, and the catch will handle it. Now the finally is sometimes you want, this is a real life scenario. Whatever happens in the day, you eat. Whatever happens in the day, you will sleep. Some things cannot be compromised, no matter what happens. It will occur. You have the same scenario in the code. Sometimes there are a section of code or block of code that no matter what happened, whether there's an error or not, you want that session to work. Whether there's an error or not, you want that session to work. And that session, you put them in what? They finally block. So whether there's an error or not. So let's start with simple arithmetic before we move to complex ones. Okay, I'll create a class. Accra City. Now in the Accra City class I've created, I have this public static void main. So you ask, so you have like the traffic light capturing people walking around and their cars and their movements. So if you see that the person is walking like drunkard or like someone who is on some Indian hemp or some stuffs, you need to throw an alert. So first, I'll try and get some input. So I'll use our scanner class. Scan is equal to new scanner system.in. System.in. System should capital S. Terminate. I'll do my import. So I need someone to be sending the feedback. So assume you have a monitoring team sitting by their monitors, just monitoring everyone in town, just like person of interest, monitoring everyone in town. When something happens, then I'll just send the description to someone. Then that person will take it and what? Handle it. So we first ask, what is happening? Then scan dot next line or next server. Then I'll say string event. So something happened. I'll capture it in a what? Event. I'll capture it in an event. Then as I capture, I know whatever is coming could be a potential threat. So I'll demarcate this area. So it's just a block. Try catch. Catch takes a condition. Just like the if it takes something. Whatever it takes should be a subclass of, I'll come to the exception hierarchy. So for now, let's say exception E. So we ask you to enter what is happening. So let me just move the whole of this. So as you are monitoring the whole of this here, so what is happening? Scan next. Then as I get the input, I'll check if or I'll use the switch statement. Discard the switch. Switch event. In Java 7, you can switch strings. But before Java 7, you can only string constant and integers or characters and integers. So here I can switch maybe if the person says kill so kill bomb fire okay. Okay. Fire terror. So we are monitoring for this event. So if whatever the person enters contains any of this, then here I'll just say raise kill alarm. Kill alarm. Now how do we raise the kill alarm? You just have to say throw some error. So we must throw the signal or throw new kill alarm exception. Now, all exception class, this is the hierarchy of the exception class. We talk about inheritance. Every exception comes from the superclass called throwable. Throwable. Now, when it comes to the throwable, we have two main types of exception. Exception which are within our range as programmers, and exception coming from the side of what? Oracle or Sun. Now it's Oracle. When I say Oracle, in terms of what? The JVM. When your JVM is not working, there's nothing you can do about it. It's either you download new one or you send your report. Now, if the exception is within your range, that's when you move to the exception side. If it's this out of memory, the machine doesn't have memory, the JVM is corrupt, any other thing, those are the errors. And those ones, you don't go there. So virtual machine error, thread death, AWT error, those are not your problem. Those are system faults. So those are the errors. So you don't go there. So what we concern ourselves with is what? The exception. But don't forget the exception comes from what? The throwable what? Class. Now, now that we are here, under the exception, you can see you have this exception, runtime exception, IO exception, class exception. Now you have a lot of them. When it comes to this side, you must know this hierarchy. Why do you need to know this? You can have one, like per our case here. You can see we'll throw what? Kill exception, bomb exception, fire exception, and what? Terror exception. So you have more than one exception. Now if you are throwing more than one exception, there's an order in which you must follow. You must always throw from the last one. What do I mean? Assuming in your code, you have a runtime exception. You also have index out of bound exception. You also have null pointer exception. And you first throw runtime exception. Since this is bigger or the superclass of all these things, this code will not be reached. So if you are throwing more than one exception, always throw it in the reverse order. The least subclass to the what? The superclass. So always throw the least subclass, then the next after the least. So you get to the what? Your superclass. But in Java 7, there's what we call multi-catch. Multi-catch, where under normal circumstance, you are supposed to catch this, then catch another one. Like if there's more than one, catch. So if this is this, here you can't catch. This is what I'm saying. Like this errors, exception, this runtime exception. So when I say runtime exception, you can see I'm getting an error because this exception is a what is exception class? This runtime exception is subclass of what? Exception. It should be the other way around. The least should come before the what? The bigger one or the larger one. So it's supposed to be like this. It's supposed to be like this. This is accepted. So this is what I mean by what? From the least sub to the what? Your higher step. Now, when you come here to, you have what we call caught exception and uncaught exceptions. Among the exceptions, you have two main types. The caught ones are the ones which you explicitly catch them, declare them by as a programmer. You say throw new this exception. That's what we'll be doing. Then also have uncaught exceptions, where that one you don't have to throw anything, but the JVM will automatically handle those things for you. Examples: when you have an array and you are trying to access an element which does not exist in that array, index out of bounds exception, you don't throw it. But if it doesn't exist, you get the error. If you are looking for a class and the class does not exist, class not found exception. So exceptions in which you don't explicitly throw them, Those ones are the uncaught exceptions, and the one you specifically throw them are the what? Caught exceptions. Now, to create your own customized exception, this is just a class. All that you have to do is what? Extend from what? Exception class. So that's what we'll be doing. That's why I came back here. So here we have 4 main what? Exceptions you are supposed to be throwing. Let me comment this way. So you have the kill, bomb, fire, and terror. So I'll create a class. I'll create kill exception. So kill exception. Always when you are naming it, it's a convention that you add exception name to it so that you know that this is what? An exception what? Class. This is your own customized exception. So kill exception. Then you must extend from the what? Exception class. I'll give it a package. So this is the kill exception. So I'll move the capacity to that one. So you have the kill exception. I'll create the rest. Bomb exception. Extending from what? Exception class. Then terror exception. Terror exception. Extending from what? Exception class. And the last one is what? Fire. Fire exception. Extending from the exception class. Extending from the exception class. Now here, I just want to do something simple. In this exception, you will determine what you want to do. So if there's a bomb exception, maybe arrest the person or do this or send a message, you determine what you want to do. So for the time, I'll just create some methods. Or you can override. This class comes with some methods, the exception class. You can override it, but for now, I'll just write a normal method. Public void bomb message or bomb notice. Then I'll just this out. Bomb notice. So I'll do the same for the rest. Let me just copy it and change it. Copy. So I'll just change this one to fire. Fire notice. The same with the kill. Kill noticed. Then the same with the terror. Terror noticed. Now that what we've done here is what we call creating your what? Custom exception. It's nothing but what? Extending from what? The exception class and giving it any methods that you want. It's just a normal class. You can give it any method that you want. Now let's come back to our class. Now that we've created our own what? Exception class. So this is what happens. So if the case is what? Kill. You just say what? Throw what? Kill exception. Just like creating a new instance. New kill exception. And if this one is true, you don't need a break. So throw new kill exception. The same with this one too. Throw new bomb exception. The same with this one too. Throw new what? Fire exception. Then throw new terror terror exception. So that's what you are saying. If the words are they do this, else if it's not any of them, I'll sys out not a threat. Now, if you are throwing it, because I made this one runtime exception, it will try and catch everything. If I remove the cache, because I'm throwing, I'm supposed to catch those exceptions. So for Java 7, I can use the what? The multi-catch. So how does the multi-catch? I will just say terror exception, then use the pipe, you know, the pipe or the or fire exception or bomb exception or what? What's the last one? Terror is the kill exception. Then you create an instance of it. Then I open curly brace. This only works in Java 7 and 8, Java 7 upwards. If you are below, you can't use this one line multiple exception unless you do catch this, catch this, catch this. Now, because I'm using a multi exception, this is what I'll do. I'll just change the method, all of them to what? Notice. So that I'll call one method. Are you getting it? Just one method. If I don't do it, I have to use the, okay, let me just. We've not used the instance of operator, right? So this is what we do. Let's proceed. I'll use it there. So in Accra city, where is 0 coming from? So we have this. Now, in order for us to know which kind of exception, I'll use the instance of here. So I'll just say if this E is instance of terror exception, then E dot terror notice. Else, if E is instance of fire exception, then E dot fire. Did I get named that one fire? Okay, still fire. Fire notice. So E dot fire notice. So I'll do for all of them. Else, if this is the use of the instance of keyword. So E is instance of. The last one is what? Bomb exception. Then E dot bomb. That one too, since I changed it. Bomb notice. E dot bomb notice. Then the last one, else. Let me add the if. Else if E is instance of kill exception. That one to E dot kill so save. I'll come here, kill notice. Now I'm done. So let's test our code. So when you run it, what is happening? When I say kill notice. When I run it again, what is happening? Bomb. bomb notice. What is happening? Nothing. Not a threat. You've seen the use of the what? The try, the true, and the what? The catch. I said we have 5 keywords. So it's left with what? Truth and what? Finally. Sometimes, and as I said, the final block is used when no matter what happens, you want that side of code to run. So you can just append it here. I can just append it here. So I just say finally. So for the finally, whatever I place here will always run. How do I know? Let me just this out. I will always run. I will always run. And let's test our code again. What is happening? Kill. Kill notice. I will always run. What is happening? Good. I will always run. What is happening? Enter. It's expecting something. So just J, not a threat. I will always run. So the final block will always what? Run. And there are situations where if you don't handle the exception this way by throwing it to for a cache to handle it, that's where the throws comes in. So I'll create a separate class, another class, tema. Then the tema, I'll just create an instance of any of those kill exceptions. Any of those exceptions. So when I say okay, let me just use normal stuff. So I'll just want to create, I'll do divisible by 0 error. So again, scanner scan is equal to new scanner system dot in system dot in. Then I'll just ask the person to enter first number. Then I'll just say int num1 is equal to scan. If I want integers, what? Next int. Next int. Then I'll just duplicate this line of code. Copy, paste, enter second number, num2. Then I'll say num1 or int result is equal to num1 over num2. Because num2, if it's 0, I'll get an error. Let's try it first. Then here I'll sys out result. So let's run this. Enter first number. That's for second number 4. Result is 8. Let's run it again. Enter 4, second number 0. You get what? This is what I call uncaught exception. You didn't throw it. We didn't throw anything. But the JVM handled it for us. And it's throwing what? Arithmetic what? Exception. Now, there are 2 ways to go about it. Either I will decide to put this in a try catch block, or I'll just say this method should do what? Throws. What's the name of the exception? Arithmetic exception. So throws arithmetic exception. Now when I do this and I run the same code for 0, it throws an error, right? Handled by 0. This one handled. It will be thrown to someone to handle it, but no one could still handle it. But this is how typically you use the throws exception. This truth means that, let me just say, if something, this